How are you, my friends? This is lecture 11 of Pre-Calculus course, Trigonometry of Right Triangles. Please, you can visit the playlist, Pre-Calculus course lectures for other lectures. Now, in this lecture, the objectives are trigonometric functions and the special triangles. If we have a right triangle, that means there is one angle 90 degrees. So we have a theta there, that's an acute angle theta. See, here is theta. Then the side facing the theta, we call it opposite side. See, this is facing, looking. We call it opposite side, y. Let's call it y. Now this side here, we call it adjacent, very close to theta. And this one, the facing 90, we call it hypotenuse, r. So we define now the sine function as the value of the opposite here divided by the hypotenuse. So y over r. So this is sine of the theta, S-I-N-E, and we make abbreviation S-I-N. Cosine function, it will be C-O-S. So cosine function will be the adjacent side divided by the hypotenuse, so x over r. These are important formulas to remember. And tangent, we call it tan theta. So it will be y over x, which is the opposite over the adjacent. So these are the basic three trigonometric ratios or trigonometric functions. Now, if you need r, you can use Pythagorean theorem, x squared plus y squared is equal r squared. So r will be always the square root of x squared plus y squared, r always positive. Now we can continue the other three functions. See, this is sine, cosine, and tan. So this is the summary here. And the other three functions are cotangent, which we call it here cotan, C-O-T, secant, and cosecant. Now, the first slide here is the basic functions, sine, cosine, and tan. If you need to find the cotan, secant, and cosecant, just use the reciprocals, because cotan, theta, will be the adjacent over the opposite. So we can see that it's 1 over tan theta. So this is y over x, and cotan x over y. Secant, theta, hypotenuse over adjacent, which is r over x. See, this is the reciprocal of the cosine. Cosine is x over r. This is r over x. Cosecant theta will be r over y, which is the hypotenuse over the opposite. So this is the reciprocal of sine. Sine is y over r. Cosecant r over y. Just remember these nice, easy formulas. Here I'm mentioning the reciprocals, just in case. You can make a summary here on this slide. Cotan of theta 1 over tan theta, or tan theta 1 over cotan of theta, or if you multiply them, cotan of theta times tan theta is 1. So number one here, I see, you can see three formulas, but actually it's the same one. See, cotan of theta, the reciprocal of tan. Tan also the reciprocal of cotan. And if you multiply them, you get 1. Same thing for secant theta and cosine theta. They are reciprocals. So you can see here three forms of the same formula. So in this slide, we see formula number 1, formula number 2, formula number 3. Each formula has three different forms. Now, let's see example 1. Theta be an acute angle. Acute means between 0 and 90, such that sine of the theta is 2 over 3. So given only one function, enough. And we have here theta is acute, so we can make a right triangle. And we need to find secant of theta times tan of theta plus cosecant of theta all squared. So we make a right triangle. I'll show you how. Just draw any right triangle you like and put theta here, but make sure sine theta 2 over 3, that's given. See, given 2 over 3. So the 2 should be the opposite here, because 2 over 3, that's the opposite over hypotenuse. This is 3 now. So what's missing is this side. So if any function is given of the trigonometric functions, That means one side is missing. So you can find that used Pythagorean theorem. X squared plus y squared is equal r squared. Let's call this one x. So we have 9 is equal x squared plus 4. So x will be plus or minus square root of 5. Now in this case, I take x equals 5 because we have acute angle which is quadrant 1. Now later, you will see that x can be negative if we go to quadrant 2 or quadrant 3 and so on. Are always positive. X and y depends on the quadrant. So we have already sine theta 2 over 3, that's given. Let's look at cosine. So I advise you, when you have questions like this, make sure you find sine theta, cosine theta, and then after that, easy to find tan theta. After you finish, you can find other functions. So start always with sine theta, cosine theta. Easily you can find the others. So tan theta will be the opposite over the adjacent. See, tan theta the opposite here over the adjacent. So it will be 2 over square root of 5. And the cosine will be the adjacent, which we found x over hypotenuse, square root of 5 over 3. Now let's continue in the next slide. So I have sine is given, sine of theta is given. I found already cosine theta, tan theta. I can find secant of theta, the reciprocal of the cosine, and cosecant theta, the reciprocal of sine. So it will be 3 over 2. Now let's put the numbers here. Secant, we know secant, 3 over square root of 5. Tan of theta, 2 over square root of 5. So when you multiply, you get 6 over 5 here. See the radicals. And then cosecant 3 over 2 squared. So that's 9 over 4. Nice numbers here. So you need LCD 20. And this is 24 plus 45. 69 over 20 is the answer. Now, question number 2 will be similar to question number 1, but in the given, we have tan alpha is given square root of 7 over 3. Alpha is an acute angle, and we need to find the value of sine alpha times cosine alpha plus 1 over cotan of alpha times secant of alpha. So we start with tan of alpha, and then we draw a right triangle. See, do we have an angle alpha? I can put alpha here, or I can put alpha there. But remember, after I replace the alpha in any position I like, so I put alpha here, then I look at the tan. Tan means opposite over adjacent, so y will be the number in the numerator, so that's the opposite, square root of 7, and this will be the adjacent 3. If I put alpha here, I can put alpha here, then this is the opposite now, square root of 7 there, and this is 3. Just make sure you understand that. Now let's say r squared is equal to x squared plus y squared. Put r squared there, x we know, y we know, so r squared will be 16. We take only the positive 4, plus or minus 4 for r always positive. So as I told you in question number 1, the first 3 basic functions you can find, tan of alpha, sine alpha, cosine alpha, or whatever angle we have. So sine alpha will be the opposite over the hypotenuse. So the opposite will be square root of 7 over 4, and cosine alpha will be the adjacent over the hypotenuse, so 3 over 4. Now let's continue in the next slide to see the other functions that we have to find. So this is tan of alpha given. The functions we found, sine of alpha, cosine of alpha. What do I need here? Cotan of alpha 1 over tan alpha, which will be the reciprocal of the given. So 3 over square root of 7. Secant of alpha 1 over cosine, the reciprocal of the cosine, 4 over 3. So I put here sine of alpha, this is sine, square root of 7 over 4. Cosine will be 3 over 4. So it will be 3 square root of 7 over 16, leave it. Now we have cotan of alpha, 3 over square root of 7 down in the denominator, and secant 4 over 3. So this will be, if you cancel the 3 here, it will be 1 over 4 over square root of 7, which is square root of 7 over 4. See, 16 and 4, we have to find LCD, multiply by 4 up and down. The final answer will be 7, square root of 7 over 16. Now, here are the special triangles and the special angles. 30, 60, 45. These are the very basic special angles. Now, let's start with this 45. This is 45, this is 45. Suppose this is 1, this will be 1, because this is isosceles triangle. We will see that later. 45, 45, this side is equal to this side. And if you put x squared plus y squared is equal to r squared, this will be square root of 2. Now, I put here a table. You can remember the table. This is 45 down here. See sine theta, 45. Sine of the 45, square root of 2 over 2. Cosine theta, this is cosine 45. Tan of 45, cotan of 45, secant of 45, cosecant of 45. So you can remember it from the triangle, special here, or you can remember it from the table, or any other way you like to remember sine and cosine, tan, cotan, secant, cosecant for these three special angles. I put here the angle in degrees, 45 degrees, which is the same as pi over 4 radians. Now let's move now to 30. 30 here, 1. The side facing the 30 is half the hypotenuse. So if this is 1, this is 2. And this will be square root of 3 by using x squared plus y squared is equal r squared. So for 30 degrees, which is in radians, pi over 6, sine 30 is half. Always you can remember that. That's a nice, easy number to remember. Sine 30 is half. And then cosine 30, square root of 3 over 2, tan 30, cotan 30, secant 30, cosecant 30. Same thing for 60 degrees, that's a special angle. 60 degrees will be pi over 3 radians. All right. So now let's look at this nice, easy example. Use the given right triangle to find the value of x times y. We have a triangle there, and there is a 30 degrees. This is 90, right? And that's y, that's x, that's 18. So let's find x times y. Now, so 30, let's call it here theta. We know sine theta opposite over hypotenuse. Cosine theta will be adjacent over hypotenuse. So sine 30, see this is the angle here. Sine 30 will be x. See that's the opposite, x over the 18. We know now cross multiply, x will be 18 times sine 30. Sine 30 from the table, see the table here, or the triangle, these are special. You have to remember them always. Sine 30 will be half. Half times 18, 9 is the value for the x. Now let's take cosine 30. Cosine 30 by the formula here, adjacent over hypotenuse. So cosine 30 will be the y over the 18. Cross multiply, y will be 18 times cosine 30. Cosine 30 we know, square root of 3 over 2, multiplied by 18, that's 9 square root of 3. Now let's multiply x and y. So the final answer will be 81 square root of 3. Let's take a higher level question. Use the figure here to find x. So we have two triangles, both of them are right. This is 50, this is angle 60, that's 90, 90, that's angle 60. We need this side here is the x. This is more work here in example 4. Now we have the 50 is given. So I said here it's a good idea to label the vertices by letters. So I put here A, this is the vertex, B, C, and D. Easy, when I say use triangle ABC, use triangle ACD, etc. It's easier. Let the length of the side AC, see this is AC, let's call it M, small m here. This AC, we have to use it. Now use triangle ABC. See now, it's easy. Instead of saying use this triangle right or left, I say use triangle ABC. So sine 60, we know from the table, square root of 3 over 2. Let's go now use the triangle. Sine 60 will be the opposite, 50 over the m. You see? Sine 60, this one will be the opposite here, 50 over the hypotenuse of ABC. So m will be 50 over sine 60. Sine 60 we know from the table, square root of 3 over 2. So it will be 100 over square root of 3. This is m. Now let's take triangle ACD to find the relation between m and x, because we need x. At the end of the day, we have to find x. So from the last slide, we find m. See m here, down m here, 100 over square root of 3. Now let's use the triangle ACD. Sine 60, see sine 60 will be the opposite, as we said, over the hypotenuse. So m over x. So what is x? When you cross multiply here, you get x equals m over sine 60. Okay, so that's what we need here. I put star here. Replace the value of m here in the equation star. So we know this is m from last slide. This is m 100 over square root of 3. You see, this is in the equation star. Divided by sine 60, and remember sine 60 still square root of 3 over 2. So this is 100 over square root of 3. And this is the reciprocal, multiplied by the reciprocal, 2 over square root of 3. So the final x will be 200 over 3. Nice number. Another, maybe I think easy question. Find the value of x plus r squared. So we have a triangle here, 45, and there is r, there is x, there is a 20 here. So let's find x, let's find r, and then we add. See, this is isosceles, I called it isosceles triangle. This is 45, and this is 45 for sure, because this is 90. Let's call this triangle E, F, and T. Triangle here, E, vertex F, vertex T. So we have 3 vertices here. So I put here the definition of isosceles triangle, a triangle with 2 equal sides. Angles opposite to equal sides are also equal. Now, so if these sides are equal, side FT here is equal TE. So x will be 20. This is 20, x will be 20. Now sine 45, the opposite, which is 20 over divided by r. See, this is the r here. And we know sine 45 from the table, square root of 2 over 2. So when you cross multiply here, so what do you get? 40, r will be 40 over square root of 2. Rationalize, square root of 2 over 2. So this is 220 square root of 2. So when you get x plus r squared, x is already 20. When you square this one, so you get 20 times 20, 400 times 2, 800, 820 is the final answer. Let's see more. Given this big triangle ABD, and there's another triangle ABC inside, given that the length of AD is square root of 15, all this, see this big one here, square root of 15. C is the midpoint of BD. So this distance BC, the same as the distance CD. Let's find x. This is the x here. Oh, so the length of the side AC, we need to find x. Also, I advise you here to stop the video for a minute or two, or at least to know the idea, have a rough sketch, or if you can find x, then you can check your answer. You can learn more. Now, let's start. I have here triangle AB, and here C and D. This is 45. See, this one here is 135. So this one will be 45, because 180 minus 135. So this will be 45. And this is already 45. Okay. Now, C is the midpoint of BD. So that means DC is equal to CB. And also, you know, isosceles triangle ABC. So this BC or CB is the same as AB. So let's call each one M. So DC, CB, AB, each one we call it small m. Now let's use Pythagorean theorem for triangle A, B, and D. A, B, and D, the big triangle, because we need to find M. So AD all squared, see this is, you see, all AD all squared is equal AB all squared plus DB all squared, all of it, which is 2M, you see? So AD given, square root of 15, AB is only 1M, DB is 2M all squared. So now simplify the equation, find M, then we can find X. Continue in the next slide, we have this one square root, this is 15, and this is 4M squared plus M squared will be 5M squared. Divide by 5, so M will be square root of 3. So this is the M here. So this will be square root of 3, square root of 3, square root of 3. Now let's use triangle ABC now to find X. ABC here, small one. Sine 45 will be M over X, the opposite over the hypotenuse. So sine 45 will be M over X. So X will be M over sine 45. M we found already square root of 3. Sine 45 will be square root of 2 over 2. So I leave the first fraction, multiply by the reciprocal, 2 over this, rationalize, you see? 2 square root of 3 over square root of 2 rationalize. So it will be square root of 6 is the X. Now this is lecture 11 that we did now, trigonometry of right triangles. After this, we go to lecture number 12, which will be applications on trigonometry of right triangles. So at the end of lecture 12, please, you can find some old exams questions to practice on both lectures together. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you that this is pre-calculus course, lecture number 11. I hope I can see you in another video with another topic. Thank you very much for listening.